In this video, we are going to solve a problem taken from the JEE Advanced Examination. Integrate the floor function of the square root of 10x over x plus 1 from x equals 0 to x equals 10. Before I move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. The floor function forces the output of this function as a whole to be an integer. So integrating this function is quite easy when we know which integer it actually gives. But the problem is we need to first find out what integer value does this actually take. So we're given that x is between 0 and 10, so we can establish the range of this function step by step, starting from 10x over x plus 1. So in fact, 10x over x plus 1 can be rewritten as 10x plus 10 minus 10 over x plus 1. Now, the first two terms, 10x plus 10, is just 10 times the denominator. So I can rewrite this as 10 minus 10 over x plus 1. Now from this, I can start off with x between 0 and 10, and then x plus 1 is between 1 and 11. Then 1 over x plus 1 is between 1 over 11, taken from the maximum, and we do the reciprocal, so it becomes the minimum. And then the maximum becomes 1. Multiplying by 10, and then we've added a minus sign, which turns the maximum to minimum again. Of course, I can add 10 as well. So then the minimum is now minus 10 plus 10, which is 0, while for the maximum is minus 10 over 11 plus 10. So simplifying, we have 100 over 11. Now we can take square root. So we know that this expression is just 10x over x plus 1. And now I can directly take square root. And for the maximum is 10 over root 11. And you may notice that is a number. For the square, let's look back at the fraction. 100 over 11 is between 9 and 10. So the square root of that should be between 3 and 4. If I take the floor function, that will give the integral part, because the range above are on non-negative numbers. So we have the floor function to be between 0 and 3. Now that means there are only 4 possible values for this output of the floor function: 0, 1, 2, and 3. If it's just 0, then we have nothing to integrate, so we can just focus on when will this function give 1, when will this function give 2, and when will this function give 3. As an example, I'm going to demonstrate how to find a range of x that gives 1 under this floor function of the square root. So if the output is equal to 1, then we have not including the floor function, but just the square root. The square root of 10x over x plus 1 is then between 1 and 2. It can take 1 but not 2. We can square each part of the inequality, and we have 10x over x plus 1 to be between 1 and 4. Then I can return to 10 minus 10 over x plus 1. That's between 1 and 4. Now subtract each part by 10. Minus 9 less than equal to minus 10 over x plus 1, and that is less than minus 6. Then remove the minus sign. We have 9 is greater than or equal to 10 over x plus 1, and that's greater than 6. Further divided by 10, we have 1 over x plus 1 to be between 9 over 10 and 6 over 10, and that becomes 3 over 5. Taking the reciprocal on each part, we have the minimum is 10 over 9 less than or equal to x plus 1, and then we have less than 5 over 3. And so we have the range is x between 1 over 9 and 2 over 3. So that's when this floor function will give 1. Using a similar argument, we can see that when x is between 2/3 and 9, then the floor function will give 2. And otherwise, if x is larger than or equal to 9, then the floor function will give 3. Here are the steps just to make the explanation less clumsy. So now we can move on to the integral. So our original integral can be rewritten as integrating from 1 over 9 to 2/3 on just 1 dx plus 2/3 to 9 of 2 dx plus from 9 to 10 3 dx. Then the integral is now really easy. So from 1 over 9 to 2/3 is just x. From 2/3 to 9 is 2x, and for the rest is 3x. Then subtracting, we have 5 over 9 plus 2 times 9 minus 2/3 plus 3 times 10 minus 9. And simplifying, we have 5 over 9 plus 2 times 25 over 3, and that's 50 over 3, so 150 over 9 plus 3 times 1 at the end. So altogether, we have 182 over 9. So this is our final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.